Good to
Sure.
go? Okay,
You're live.
cool. So I'm Jeff Utter, and I'm going to be talking about debugging live systems. So like I said, my name is Jeff Utter. This is me in another life. I played the double bass. I work at Bleacher Report, and I live in Topeka, Kansas. I have 2 cats and a dog. One cat's name is Kilgore. He likes to sit on his face. And the other cat is Jasper, who's very charming, and a dog, Maya. And like I said, I'm going to be talking about live debugging. Now, what is live debugging? To start, it might be easier to talk about what it's not. So it's not tracing, it's not monitoring, not step debugging. It's kind of your last resort for production issues. Now, has anyone, I don't know if we can actually get like a show of hands if people want to wave, or there's like a thing on Zoom where you can like raise a hand. Has anyone like done this kind of debugging in Elixir systems before, namely like using something like Recon or Debug? Cool, seeing some reaction. Has anyone never like have no idea what I'm talking about? Maybe come from another language like Ruby or something where you can't really debug live systems. You can maybe run like pry or something, but you probably don't want to do that on production.
I come from other languages. I was just testing the reactions.
Yeah, cool. So like I mentioned, it's not tracing, but we can maybe start there as like a departure point. So with tracing, sometimes the error is really obvious, right? You get a trace like this. There's red traces and a nice big error message in red. It tells you stack trace and everything. You can see where the problem is. And that's great when you have those kind of problems and you can see exactly where it is. But sometimes you have other problems and the trace looks like this. It's fine. You can see it took 4.5 seconds. That's probably not good, but there's no error. It doesn't really give you any information or anything to go off of. So in these kind of cases, you really have to have ways to introspect a running system. And the Beam has a few different ways to do this. First thing you're going to need is a way to connect to the running node. And I'm not going to go into this too far because it kind of varies based on your environment and your deployment strategy. But you know, depending on if you're running like Mix directly or if you're using Distillery or Elixir releases. If you're running with Mix, you might connect to the box and run something like this. IEX, you have to give the session that you're starting a name, and you have to use the same cookie as the Beam instance that's running that you want to connect to. And then you use the -- remsh argument and give it the name of the running instance, the node name and the host name. If you're using one of the types of releases, Distillery or Elixir releases, I imagine the other ones that are less used now have something similar. It's kind of built right in. You just do like, you know, /bin release remote console for Distillery, and I think it's just remote in Elixir releases. And either way, regardless of what means you use to get to the console in your system, it'll drop you to a shell. So what do you do when you get to the shell that's useful? Like I said, Elixir has, well, it's not really Elixir, Erlang has a lot of tools built in for this as part of the core of the Beam and OTP. And there's a few. So you have Erlang Trace and Erlang Trace Pattern, which is what most of the other tools are built on. And we'll talk about this first because it's kind of important to understand the fundamentals. It's not, I wouldn't recommend this as like your go-to tool for this kind of thing, but it's important to know what it is and how it works. There's the debug module, which builds on Erlang Trace and Trace Pattern. There's Debugger, which is kind of more for step-through debugging, not something you'd use in production, but it's built into the Beam either way. And the sys module has some handy utilities to introspect like the state of processes and things. I'm also not going to talk about that just for sake of time, but it is really useful. And there's also sequential trace, which I haven't used and I'm really curious about. So I'll touch on that very briefly, but I personally don't know much about it. Okay, so Erlang trace. It's a built-in function, and it's, like I said, it's the foundation for all other tracing tools in the Beam. And whenever you use Erlang trace or Erlang trace pattern, you have to give it a process that it'll send all of the traces to. And like, it doesn't give you anything out of the box. So you have to provide this, which is kind of one of the reasons why this isn't the best solution for production, like using this directly. But for all these examples, I have like a really naive tracing process. You run start on this module, this tracer module, it spawns a loop, and the loop simply receives a message and inspects it and then continues to loop. Totally not production safe, but it's useful for these examples. Okay, so with Erlang trace, you can trace a process. And for that, I have this other little process that runs in a loop. It basically just echoes back to it what you give it. So you start it, it runs, spawns a process, runs in a loop. The loop receives a message that is a tuple, the process that it's coming from, and the message sends the message back to the process that it came from and loops again. Also have this little convenience function on the module called call. You just give it your PID and a message, and it sends the message to the process and waits for the reply and returns you the reply. Nothing fancy, but for the sake of example, this is the process that we're going to be introspecting and debugging. So when you use Erlang trace, you have to start the trace process, and you have to have the process that you're tracing. So in this case, I'm starting my echo process, and I'm starting my tracer, which gives me 2 PIDs, and then you call Erlang trace. You give it the PID of the process that you're tracing. Well, actually, here, this will walk through. So you give it the PID of the process you're tracing, and then the second argument in the documentation is called how. It's either true or false, and when it's true, it starts tracing, and when it's false, it stops tracing. I don't know why it's called how, but that's what that argument seems to be referred to as. And the last thing is a list of options. Here we're giving it all, which I'll talk about later, and then this other tuple of trace, and then the process to send the traces to. And then when you interact with the process that you're tracing, in this case, the echo server, it does what it would normally do. So it sends the message to the echo server and receives the reply, which is hi. And then it dumps out all this tracing because our tracer was just doing IO inspect. You could do something else. You could like ship those traces off somewhere, or you could log it some other way, or do a whole variety of things. But in this case, we're just dumping it to the console. And it looks like this. It's a big tuple with a variety of information. I'll kind of go through some of these fields too. The first one is trace TS. It'll either be trace TS or just trace. The TS stands for timestamp. And because we use all above when we set up the trace, that provides like a default selection of options, including the timestamp one. So you get these traces that include a timestamp. The next thing is the PID of the process that was being traced. So if you were like tracing a bunch of processes, you could know which one this correlates to. The next one is like the event of the trace, and there could be a handful of things here. The first and the last one are scheduling. So in means that the process was like scheduled in and it's running. Out means it was scheduled out and it's no longer running. And the receive and the send are just that, the receive and send messages that that one process does. And then there's some details about that event. So for the in trace, it's saying like, this is the function that was running when it got scheduled. And then for the receive, it's saying like, that's the message that was received by the process, and send is the same thing, the message and where it was sent to. This next argument is 3. I have no idea what it's supposed to correspond to. I tried reading through the documentation and I couldn't figure it out. So if anyone knows, let me know. And this last thing is the timestamp. It's in the same format as returned by the now function in Erlang, which is megaseconds, seconds, and microseconds. I honestly don't know what a megasecond is. Is it like a million seconds or something? But you can see that like in the last position of the tuple, the microseconds, it progressed between these traces, right? The first one is something 41, and the next one it's 4 microseconds later. So you can see the timing of these events and how they relate to each other. Like I said, there's a bunch of options you can send you can give it when you're setting up the trace. This is from the documentation. There's a lot of stuff. So I'll talk about a couple of them that are maybe the most useful. There's send and receive, which is showing you the messages that the process sends or receives. There's call, which is used when you're tracing functions, which we'll get to in a second. There's running, which shows the scheduling in and out traces. And garbage collection. And this can be useful, like if you have a process that might grow a lot in memory and you kind of want to see like when do the garbage collections happen and how often do they happen, and maybe like things like that. So is the process being garbage collected a lot during its lifetime or never? And in the case of our example here, it didn't do enough of anything to need to be garbage collected. But you can trace them either way. So that was tracing a process when you have a process that's running, but maybe you have some code that you want to see is it being hit? Is it, what is it doing? And you don't know what process is going to be calling it. So it could be like in a module, it's called by like an HTTP controller, right? You don't know what process that's going to be necessarily once you're in the console, because it gets spawned a new process for each request or whatever. But you know that you need to see like what's going on when this function's called. So it's very similar to tracing a process. You start by starting your tracer that's going to receive the tracing events, and then you call Erlang trace just like before. But now, now instead of giving the process as the first argument, you give the atom all, which means it'll trace all processes, both like processes that already exist, processes that are new. I think there might be other options where you can say like only trace processes that are created after the trace is set up or whatever. Again, that second field, how, is true because we do want to trace. And then in the previous example, we had all here to give it all the options, but now we're just going to use call because we're only interested in tracing function calls. And then we give it the tracer to send it to. Now, this is different from before. We're calling Erlang.tracePattern, which is how you define like what the function is that you want the trace events from. And you can give it, there's a few different ways you can specify this. But you can, in this example, we're just going to trace like the down case functions. Ooh, super interesting. But you give it the module and the function and the arity, and it'll trace that. So you can see when I call string downcase foo with uppercase foo, it gives a trace that looks like pretty similar. I didn't give it the timestamp option, so there's no, it's just trace, not trace TS. The PID that it was that called that function, which in this case was my IEX shell, and then the module, the function, and the arguments that it was called with. Now, that's not like the most useful, tracing a function like just by the module and the function and the arity, right? Like, especially in a live system, it could be being called like 1,000,000 times a minute or something. Maybe that's a little hyperbolic, but it can be called a lot, and like maybe most of the calls are working fine and you don't care about them. So you can also pass it what's called a match spec. Yes, so you can have match specs, and you set it up similarly. You use the same kind of thing to set up where the trace is going to, and then we're tracing all processes, right? And then we're tracing function calls, but now you can generate a match spec, which is a data structure that if you just glance at them, they're like pretty gnarly, but there's some helpers to generate them. And we'll talk specifically about what this is doing later. But if you look at the last line here, that's what a match spec potentially looks like. And it lets you do things like saying, I only care about this function when it's called with a certain argument in a certain position or something like that, or when it's called, yeah, like you can get really specific with kind of guard clauses, and you can use any like normal guard clauses for functions on it. We'll talk more about this in a second though, but then when you pass that to the trace pattern and you string down case, so if we look at the debug fun2ms, it looks like kind of like a function, but it has an argument. We're saying when the first argument is the uppercase high, then we'll trace. And the return trace thing is part of what we'll talk about in a second. But when you string down case now with foo, nothing happens, doesn't get traced. But when we string down case with high, we get the trace like we expected. And you'll notice that we get two traces now. One is the call, and the other one is the return value, right? So you can see that it was called with uppercase high, and then it returned lowercase high, like you would expect. And that has to do with the return trace thing. But what on earth was that like big gobbledygook of code to let us generate the match spec? So we have this function. It's part of the debug module called fun2ms. You don't need to use this to generate the match specs, but especially if you want to do anything significant with them, you probably want to use this. It looks kind of like a function. You can use most guards. You can actually use variables. So like this could be like fn s when s equals, and then a variable that's declared outside of the match spec, which you can't do that with functions. But as far as arguments, like if this was a multi-argument function, you would just have like fun, like a comma b comma c. You don't do that with the match specs. It has to be wrapped in a list. I think if there's only one argument, you don't have to wrap it in a list. And then the return part, like the body part of the function, gets weird in Elixir. And it's I kind of have a little hack to work around that. So in Erlang, if you look on the left, this code would work. It's a match spec for a function that has two arguments, and it's saying when the first argument is greater than 3, return trace, like as a function. And then under that's the spec it would generate. So if you look in the spec, the third thing in the nested tuple is, I guess, the atom return trace wrapped in like as a single element tuple. It's kind of weird. But when you do this in Elixir, so if you look on the right side, this is like the equivalent Elixir code, you get an exception because you have this thing that kind of looks like a function, and it calls a function inside it, return trace. And when the Elixir compiler tries to do something with this code, it's like, what is this return trace function you're calling? No idea what that is. So the kind of workaround I have is to use the atom return trace, but then it's not wrapped in a single element tuple, and I couldn't just get it to return a single element tuple. So I'm just using put in and access to like replace that thing in the list. It's not the best way to do this. If you're doing this a lot, there's a library. There's a library by Eric Meadows Johnson called ex2ms, which deals better with the Elixir syntax for this. A nice thing about this, though, is you don't need to generate the match spec on the machine that you're debugging on. So if you don't want to have like ex2ms as a dependency for all your production code, you could just have like a little project with a mix file that has that dependency. And when you need to debug, you can launch it, generate your match spec locally, and then just cut and paste that data structure into the system that you're debugging. And I had a more complex example. This did not format correctly, so we won't really look at it. But the idea here is that this can like let you do really interesting things. So the kind of example, partially real world example that I have in mind here as like a good example for this kind of stuff is I was working on a kind of like a chat system where you have multiple users in a channel and they send messages to each other. And if they don't have it open, it'll send messages to another system that will eventually give them like a push notification on their device. And I had an individual user who happened to be a manager saying like, I'm not getting my push notifications, right? Like other people maybe are getting them. I haven't heard anyone else really complaining about it, but one important person saying, I'm not getting my messages. So with a match spec, I could like debug the function that should be sending that message out to the next system down the line and see like with this person's user ID and the chat ID, it's actually being called in production, right? It's hitting this code and I can see that it returns okay, like it's being handed off to the next thing down the line. And it's not like the problem isn't here with this system, right? And using a match spec, you can do that. You could say like, only trace when this function has this UUID in the third argument and this other UUID in the fourth argument or whatever. So match specs are like super powerful for really honing in the debugging stuff. Okay, so that was Erlang trace and Erlang trace pattern. There's some better ways to do this that are more robust for using in production. One of which being the debug module, which is also built in. It's a wrapper around Erlang trace. It handles starting the trace process. Like before I had that tracer that I had to manually start. Whereas my tracer was like 3 lines of a loop. The Erlang trace one is about 150 lines of Erlang. So it's way more robust than that example I had. It also supports tracing other nodes, which isn't something I've personally used. I honestly didn't know it could do that until I started putting together this talk. So now I'm like really interested in being able to use that. But I'm gonna kind of show the same basic scenarios, what that looks like with the debug module. So I'm starting my Echo server and you have to start the tracer, but you don't have to like keep track of that PID. So the second chunk of code here is debug trace. And then to trace the process, you use debug.p and the PID of the process you're tracing, and then a list of options. Now, the debug module, it's like super powerful and useful, but like the interface is also fairly complicated. There's a bunch of functions that are named things like P and TPL and CTPL, and all of them have arities from anywhere from like 2 to 5. And it's really hard to keep track of them and what they do. But the P1 is for tracing a process. And then, sorry, there we go. Wasn't looking at the same example. But so it's like debug.p, the PID, and the options. And then when you call the process, it has output that looks like really similar to the Erlang trace example, right? It's showing I think the process that, honestly don't know what that first process is. That would be so that's the process that I'm tracing. And then the 0109 is the process that called it. So probably my shell. But it has like the same kind of things. It has in and out, right? The first and last ones. And then the 2 in the middle are send and receive, indicated by like the double arrow shovel and the PID and then the bang. It has the timestamp too, just like the Erlang trace one does. And then you can also stop the tracer. Now, this is something I'm not 100% sure about, and someone can probably tell me. I looked in the documentation and it doesn't explicitly say this. I read some of the source code and I think it does what I think it does. But so one of the problems with Erlang trace is that tracer process that I started would run forever. And maybe you don't want that on your production system. So I think debug will link, when you start the trace process, it'll link it to the current process. So when you like quit out of your shell, it kills the trace process cleanly. I'm not 100% sure on that. I know recon does that for a fact, which is one of the reasons why in most cases you want to use recon, which we'll talk about in a minute as well. But it's just something like I just do this kind of out of habit to be extra sure that it's actually stopped the tracer, because you don't want to leave traces running if you're not, if you're logging off or not using them or whatever. And you can also trace a function with the debug module. You start the tracer, you tell it to trace all processes, and then here's where that like debug.tpl comes in. And it's kind of similar to the Erlang trace pattern. You give it the module, the function, and then this :x I'll talk about in a second. But then when you call the function, it looks like really similar as before. Now you'll notice it has, it's a little bit longer, right? It's showing the call. When I called Erlang string downcase with uppercase high, then it calls Erlang string again, but this time it's calling like a 2-arity version. And then the 2-arity version returned high, and the 1-arity version returned high as well. So this has a return trace, and it's also tracing all arities, which out of the box is nice if you don't really know like what arity something's going to be called with. And it's showing the return trace too, which is handy. And that's all because of that little, and then I stop it. That's all because of the Atom X. And I couldn't find, like I read about this in some article somewhere, and I couldn't find it again. And I know that this, like there's a couple shortcuts you can use here rather than providing all the options. But I don't know like specifically what the Atom X does. And there's also the Atom C. I know that's for call when you're calling like debug.p. But the X, I'm not sure what all it does, but generally it does like what you want to do most of the times. It does return traces, and it does all the arities. And I tried searching the source code for the debug module for this, but in Erlang, it wouldn't have a colon in front of it. So just searching for the letter X is like really, really hard. And it didn't come up with anything useful. And rather than just calling debug.tpl with like module function, you can also provide it with a match spec. So you can use those same match specs to get more specific tracing. So there's some pitfalls with Erlang.trace and debug, more so with Erlang.trace. Arguably, so the interfaces are pretty complicated, especially the debug module. Like there's a lot of different functions you can call, and they all do slight variations of each other, and they have a lot of options and a lot of different arities you can call them with. There's a potential for dumping unbounded amounts of tracing, right? If you trace like a really common function and you don't give it a match spec and it's called a bazillion times, you'll get all that dumped to your console. Unless you like provide a custom tracer that takes care of that. And that's one of the things that recon does. There's some ability to deadlock. I think Erlang trace works around this, or sorry, I think the debug module works around this, but I don't think Erlang trace does. So for example, if you trace a function that the tracing process uses, so mine was like using io.inspect. If you traced io.inspect, and then you called io.inspect, and then the tracer calls io.inspect, you get a deadlock because it just keeps looping tracing itself. Yeah, so this is where recon comes in. It's a wrapper around Erlang trace again, written by Fred Hebert, and it's production safe. It links to the shell, the formatter that actually like dumps out the code, links to the tracer, and it gracefully shuts down when you disconnect your shell. And it also enforces a limit to the number of traces it'll do. So I'll just show, oh, and it only runs on a single node, which is in some cases a shortcoming, I guess. Although, like I said, I didn't even know that the debug module could run multi-node until I started putting this together. So it's fairly useful in most cases. So how do you trace? It only traces functions, but what does it look like to trace a function with recon? So you just set it up like this. It's one line, recon trace.calls. You give it a module and a function, and then you can give it in the third argument here, return trace as an atom. You don't have to do any kind of fancy manipulation to try to call a function that doesn't exist. And this last argument is how many times it'll trace before it stops tracing. Yeah, so returns a trace and then limits the number of calls. And then when you call the function, it outputs this. It shows, has like a little timestamp, not really a timestamp, but it shows the time that it was called, the process that called it, the module that was called, the function, and the arguments it was called with initially, and then the return of it. And then it shows, you'll see here that recon tracer rate limit tripped. And one thing to know about this is that, so I specified on the previous example 2, and if you're using return trace, which shows the, what the function returned, you have to give it 2, I think, because it's just counting the number of calls to the tracer process. So you get 1 call when you call the function, and then 1 call when it returns. So if I put this as 1, it would only show the first trace of when it was called and not the return trace. So you have to, like, if you want to check 5 full invocations of it, you'd have to trace 10 times. But after those times, it stops the tracing, right? So you don't have to worry about it like dumping gobs of stuff to your console that's like too much to sift through, or that would like cause a performance problem because has to write out so much IO to your console or something. And again, the third argument can be a match spec. So you can do string down case and then give it like a match spec that's really specific. And you could also give it like, there's a few other options in the docs. You can give it like a PID if you only want to trace functions called by a certain process, but you can't trace like everything a process does. So this is 3 kind of ways of tracing on the Beam. We had Erlang trace pattern, and the debug module, and recon trace. Now recon is like a third-party library, but I recommend that you include it in pretty much everything you deploy, because you don't know you need it till you need it, and it like doesn't have any kind of runtime cost unless you're using it. What else is there on the Beam? Like I said at the beginning, there's sequential trace, which I'd like to learn more about. I think basically the idea is like, rather than just tracing what one process does, you can set up a sequential trace that will trace the call to a process, but then any other call that results from that. So you can get like a view over time of how some processes interact. I'm also interested in like other ways to do production safe debugging across nodes, whether that be the debug module, or if you could do something like recon that's like a little bit simpler and more focused, that was like really, really production safe for running a distributed Erlang. Imagine it would be pretty complicated to do that well and safe, but it's still interesting because, if you're trying to debug a web app that's running across, maybe you have like 15 nodes and you're waiting for a call that you're tracing for like a specific user or something, and you're connected to one node, and maybe that call will hit another node and you'll never actually be able to trace it. So being able to run distributed tracing, as long as you're running distributed Erlang, could be really useful. That's basically, also the sys module I mentioned at the beginning. There's some handy things in there like sys, I think it's get state, which you can get the state out of any process like a gen server. And that can be really useful if you're trying to debug like, a long running process and you think it should have some state or be doing something at a certain time and it doesn't seem to be working. So that can be really handy. But that's basically it. Here's a bunch of resources. I'll post the slides somewhere, either as like a Git repo or something. If anyone wants to read any of these, they're really useful. And now I've got time for questions or comments.
Yeah, a question in the trace output.
Mm-hmm.
You have the PIDs of the process being traced. If the process was named, would that possibly show up in the output, or just
question.
PIDs?
I don't know. I would think not.
Okay.
But I honestly don't know.
Thanks.
I suspect, though, you could do some kind of lookup on that, like transforming the data. So I imagine there would be ways to figure that out. I don't know how. I'm shooting from the hip.
Yeah, and that's a really good a good point that like, especially when you're using, so with the debug module, like it provides you with a tracer, but I think you can give it another module that handles receiving the traces, just like you can with the built-in Erlang trace and trace pattern. I imagine, I mean, you could probably build some pretty darn complicated tracing stuff that could give you a lot of insight into things. But you have to be careful that you're doing it in a way that won't impact production traffic too much. And that kind of got me thinking, like, would it be wise to like build tracing functionality into processes that I'm building for other things, like kind of set them up so I can just like call the module and call .trace and it'll like instrument itself and do something that I know useful with the traces, right? And like have like a really kind of custom tracing experience for some of the stuff I build. And that might be an interesting thing to think about. Okay, I'm gonna stop sharing my screen, but like if anyone has any more comments or questions, or if anyone has any other experiences with like tracing in other ways or other tools, that'd be really cool to hear about too.
Hey Jeff, quick question. So what have you used at Bleacher for tracing stuff?
Yep, we don't like have any standards around that or anything, but personally, I like every project I start and other people's projects, I go in and put recon in them. There's also another module we don't use, but there's Rexbug, which I think is very much in the same like spirit of recon. It's built on the Erlang library Redbug, I think. But I think it tries to have like the same goals where it's production safe and a simpler API compared to debug or whatever. But yeah, personally, I usually go right for recon, like one of my first tools I pull out in most situations.
Cool.
And actually, I think I do want to paste, I could probably paste it in the Zoom chat, that match spec that didn't work. It didn't show up right in my slideshow because it's kind of interesting to look at. I just pasted it in the chat, but if you just, mostly what I'm getting at is the output of the match spec. That's probably something that you don't really want to write yourself, especially if it got any more complicated than that. And you also have like, these are match specs for functions, but you have similar things for ets where you can like make match specs for pattern matching keys and ets or whatever. And they're fairly similar in how you construct them, except for instead of using debug fun2ms, it's ets fun2ms. But when you get to like the conditions on the arguments, it can get pretty gnarly.
I went to a 4-hour, or no, an 8-hour tutorial, like I'm gonna guess 3 years ago at ElixirConf on debugging. I got more out of your 40-minute discussion than I did out of that 8 hours. Sorry if you were one of the people who presented that one. But anyway, I guess there might be people in the room who were. Anyway, that was really good, Jeff. Thank you.
Yeah, thanks.
It was good, Jeff. Good work.
Yeah, I actually just did this the other day in production for the first time. I had never used recon before, and we have an Erlang system for accepting events that I've been doing a whole bunch of modifications on. And I asked the guy who's Tristan Slaughter, who's in charge of this project, hey, can you please tell me why I'm not seeing these errant 401s in logs? And he goes, oh, well, we don't log that stuff. He goes, you're just gonna have to trace it. And I'm like, okay, cool. So once I did it once, it's super straightforward. I was very excited about it, but definitely there are some of the syntaxes that you showed or arguments that you showed were pretty complicated, but I felt like recon was fairly easy to wrap my head around.
Yeah. And that's kind of why I save recon for last, because it's important to know like what it's doing under the hood and what other options are out there. Like if you need to trace a process directly, you can't do that with recon, but it's just so easy like compared to any of the other options. Like recon is just easy. And so it's probably what you want to use in most cases. One thing to note, it's an interesting thing that happened the other day when I was tracing something. I don't know if this is a fault of recon or just the tracing in general, but if your system's under like really, really, really high load, like the CPU's maxed out for minutes, I was tracing something in a situation like that, and my trace had just never appeared. Like I was sure some code was being hit, and I just never saw my trace. So I don't know if there's some kind of, there's probably a timeout on the receive blocks and the loops or something like that, where like, you know, it was waiting for the trace, and the tracing process was descheduled or something for like a minute or something like that. And things were probably timing out behind the scenes or something like that. So that was just a little weird, unexpected gotcha. If your stuff's like super CPU bound, it may not help, but that's the only time I'd seen that. So it may have been something else entirely as well.
Very cool. All right, Jeff, if it's all right, I'll stop the recording.
Yep, go for it.
We can just socialize. Thanks, everybody.